All right, now that we have coordinate systems out of the way, let's do a very brief review of some vector algebra concepts. In particular, let's talk about the dot product. So basically, the dot product tells you how much are two vectors aligned with each other. So if they are perpendicular, you could say that they're the most unaligned that they could possibly be. And so a vector dotted with a b vector will equal 0. On the other hand, if A and B are in the same direction, perfectly aligned with each other, that's like the most aligned that they could be. And so if you and so the dot product will simply be the product of the two magnitudes of the vectors. Now, if they are only partially aligned, then if you know the angle between them, the magnitude or the dot product will just basically be the product of the magnitudes times the cosine of the angle between them. One thing that's important to always remember is that a dot product between two vectors always spits out a scalar, just a number. It doesn't have a direction. It just is a number that tells you how much are two vectors aligned.
Good job.
So one thing I want to mention is that when we use unit vectors, the dot product becomes really nice and easy. We don't have to try and figure out like those angles between the vectors and go through a bunch of trigonometry. Basically, if you've got like two vectors here um, with a, y, and z components, then to find the dot product, you simply just multiply their components together and add them all together like that. It's that straightforward. And the cool thing about this is that when you're doing it in this unit vector notation is that it literally works with any coordinate system. So like this could have been, if you were doing spherical coordinate system, you could have done a hat r, a hat a hat theta or a theta and a phi, and of course you'd have your this would be r hat, theta hat, and phi hat. But basically it would all work the same way where you just multiply out all of that stuff. So there's another thing to appreciate about unit vectors. The cross product is another really important vector operator in this course. So basically what the cross product tells you is it tells you how perpendicular two vectors are. So if you have two vectors A and B and they're perfectly perpendicular, then the magnitude of A cross B is going to be just the product of their individual magnitudes. If, however, two vectors are completely aligned, they're not perpendicular at all, they're the least perpendicular that they could be, then the magnitude is going to be 0. And then something in between, if there's an angle between them, then you have to multiply this by the sine of theta there. So one thing that I'll point out though is unlike the dot product, the cross product always, you put in a vector and it always spits out a vector. It is a vector and its direction is determined by the right-hand rule. So the right-hand rule basically is what you do is you take your hand and align it with the first vector here, so A, and then your open palm needs to face the other vector that you're crossing into, and the direction of your thumb is the direction of the cross product there. That's how we define it there. And what you'll find is because of that, A cross B does not equal B cross A. They have different orientations. So one would be out of the board, one would be into the board. And so that's something that you keep in mind when you're doing these calculations. All right, so with the cross product and unit vectors, it's pretty cool the way it works too. Turns out that A cross B, if you have two, um, two vectors with x, y, and z components, and you've got your unit vectors there, you can basically just put it into a matrix format here and uh, apply the determinant operator on this, and you will actually get A cross B. So it's very systematic, and it works exactly the same way with other coordinate systems. So in future videos, I will be doing some more examples with all of this stuff. I know that a lot of the things I've been covering has just been more theoretical, but we will get to some more concrete examples. We just first kind of need to make sure we have some sort of understanding before we just like dive right into it. So thanks for watching, and I'll see you in the next video.